frames.
Yeah. So in MAC header, right? So we are having frame types. So if we are specifying their backend frame, okay, so during that time whatever frame will come, that will act as a backend frame. Okay, so based on the configuration in the MAC header. So backend frames are also referred to as a backends throughout this specification. So we, instead of backend frames, we can also send we can also call the backend frame as backends. Okay, so coming to the MAC header, okay, when we are transmitting the backend frame, so during that time what all the things, how we have to initialize the MAC header, you see. So the protocol version is 0, as we already discussed. This is the first revision, okay, so it is 0,
and security bit is also set to 0. That means what is this MAC frame payload is not
secured.
Yeah, that means not encrypted.
Then acknowledgement is 0, means no acknowledgement, okay, for backend frame. Then frame type, as we initialize 0, so 0 denotes to backend frame. So frame subtype is reserved, so in that case we have to send 0. So retry is also reserved. So destination address is broadcast address.
Yeah, we know that backend frame is a broadcast frame, right? So
broadcast address is having some range, right? We have to transmit within that range.
Yeah, so it will have that address range.
Right. Coming to the next is source address. So source address is device address of the transmitter. So okay, so the address of the transmitter.
Okay.
Then sequence control and duration. These all things we'll see in forthcoming slides. Okay, how to.
But in 16.2 we have seen the definition for sequence control, right?
Right.
So now we'll see the 17th chapter. Okay. 17th chapter 1.9, right?
1.9.3.
1.9.3.
Right.
This one.
Right. Sequence control. So you see here sequence number they are talking.
Yeah, sequence number field sequence number field value is used for duplicate deduction of frames sent using the immediate acknowledgement policy. So we have seen the four combinations of acknowledgement policy, right?
Okay.
So what is that? Block acknowledge, immediate acknowledge, no acknowledge, like that, right?
Okay.
So if the receiver detects the frames with the immediate acknowledge,
okay,
so during that time, in order to duplicate that frame, it is using the secure frame number.
Right.
Sorry, sequence number. Okay. It is used for both duplicate deduction and reordering of frames. Suppose in a wireless network we know that every frames are in terms of packets it will transmit, right?
Okay.
So the router may route in a different way, right? This is a general logic, you know.
Okay.
It may get data at different order.
Okay.
So we know that anyway the entire data will be segmented and it will be fragmented, right? So it may receive in a different order.
Okay.
At last it has to do the sorting.
Okay, right.
I mean reordering of all those frames. Then only it will get the real meaning of that packet, right?
Okay, right.
So for that it's used. Okay. And a device will assign each MSDU or MCDU transmitted a sequence number from modulo counter.
Okay, right.
Modulo 2K counter. Device shall assign same sequence number to each fragment of MSDU or MCDU. So we have seen PSDU and PCDU, right? Here MSDU means what? MAC service
Data unit.
Yeah. A single sequence number applies to all MSDUs contained in aggregated data frame. So this is another type of frame, aggregated data frame. Okay. So for that aggregated data frame will use single sequence number.
Okay, right.
For all MSDUs. Okay, then
a device shall increment the sequence number counter by 1 for each transmitted aggregated data frame. So once
clear, right?
Once we are transmitting the data frame, then we have to increment the counter
for the next one.
So the device shall be dedicated counter for MCDU. Okay, so one counter will run independently for MCDU's calculation. So the device shall use a dedicated counter for each sequence of MSDU addressed to the same destination address with same delivery ID using B acknowledgement policy.
Yeah.
So one more counter they are telling for sequencing of MSDU addressed. Okay. So they are talking about some counter. So device may use one counter for all other MSDU and may use a dedicated counter for MSDUs with same delivery ID values addressed to the same destination address.
Yeah, that means what? Device may use a single counter.
For all the MSDUs.
Yeah, or it may use the same counter for delegated to all the MSDUs. Okay. In each beacon frame transmitted in a super frame, a device shall set the sequence number field from dedicated counter that increments once per super frame. Getting? So that counter also will increment up to 2k. 2k means 2048. For that, how many bits we need? For 2k, 11 bits, right? So our counter will have the
11 bits.
11 bits. Okay. Now we'll come back to our normal discussion, where we are in beacon frames. Okay. So for beacon frames, the sequence control will set according to that one.
Right.
Next, duration. We have already discussed about duration, right?
Right.
So anyway, while discussing about 17th chapter, we'll again read that one. Okay.
Right.
Then more frames and access method are reserved for beacon frame. This is already they have mentioned, right?
Okay. Right.
These two fields will be reserved for beacon frame, like that. So we have seen the MAC header for this beacon frame.
Right.
Now MAC frame payload for this beacon.
Right.
So what are all the frame payload content?
If you see
Beacon
that
parameters.
backend parameters are there, then information elements. Okay.
Yeah.
So information element is from 1 to n.
Yeah.
Okay. So what they are trying to say is the information element that may be included in beacon frames are listed in table 104 16.a. So we'll see table 104.
Yeah. 16.8, right?
Right. In 16.a.
Yeah.
16.
So that is what our last topic.
Right.
Information elements.
Okay. Right.
Okay. Yeah.
Okay. So
This is